Hello guys, welcome back to the next lecture, and today's third video we're actually learning about chemical kinetics graphs. So if you observed the mock kind of NEET 2026, you must have seen that there were so many graphs, especially in physics I would say. So graph questions definitely play a great role. So we're going to do them from chemical kinetics because there was a question asked in this NEET as well, and it can be asked for the next one as well, right? So moving on. So we're actually learning all about these graphs from zero order, first order, and second order too. Okay. So let me start from the zero order. So the first thing that you might have to know for all these graph based questions is simply the formula for zero order integrated rate equations. Okay, so let me just put down few formulas that we might have to know, which is like kt is equal to a naught minus a. So this is basically initial concentration and concentration of air. Okay, so this is one of the formula. And you also have formulas like x is equal to kt, and x is basically with respect to the concentration of products. And if you also talk about half-life period, you kind of have the half to be a naught by 2k. So I'm sure you remember these kind of formulas, right? So now let's dive into the diagrams. So we have the first one with concentration of A on this axis and time on the other one. Now let's see what is going to be the graph if you consider this equation. So if you're going to take it as, it's going to be C. So it's going to be X, M, okay. If you just take it something like this, and if you just make it into y is equal to mx plus c, so if you take a is equal to minus kt plus a naught, so you're going to have a negative slope, right? So m is equal to basically minus k, and this intercept would be a naught. Okay, these are some important simple stuff that you need to remember. Let's go to the next graph. I'm just going to put it on this side. The next graph is for a rate and concentration of reactant. And remember, you'll have to remember the formula R is equal to K times A bar 0. So it does not depend on concentration of A. So it's going to be a straight line. Moving on. So let's put concentration of products and time. So we know X is equal to KT. It's going to be a straight line to the origin. Why select this again? Am I not able to put the straight line, or it's just the okay. And last but not the least, what if I put t half and a? So you know t half is a naught by 2, a naught by 2k. So it's again going to be a straight line because it's going to form y is equal to mx. So straight line to the origin. So these are all that we have got for zero order. Let's talk about first order, because in first order there's a lot more and it's going to be fun. Okay, let's move on to that. So a few reactions you might have to know for first order. Not reaction, oh, formulas. I don't know, reactions are definitely always on my head. The first would be to know R is equal to K times power 1. I'm just differentiating R and I'm putting reactants as A, okay? R is the rate of reaction here. Right. And I could do Ln R is equal to minus Kb plus R naught. Or I could do minus Kb, or I could do e power minus Kb as R by R naught. And from this one, I could also take it as log of R is equal to minus K by 2.003 T cross log R naught, similar to Ln, just with a 2.303. Okay, so these are the general kind of reactions. Now, if you talk about half-life period, you also have stuff like 0.693 by K. Okay, this is one of the most important ones. Okay, now let's go. Let me just put these. I think of doing smart work. Okay, whatever. So the first one would be a rate as well as concentration of reactants. It's going to be a straight line because what is the formula? R is equal to K times A. Next, let's take simple T half as well as concentration of A. It's going to be a straight line parallel to concentration because it does not depend, because the formula is 0.693 by 2. Moving on, let's go to the hard part. Let's say we take concentration of A as well as time. So how is the actual reaction? It's something like A is equal to A naught e power minus Kt. So what are we going to take it as? An exponentially decreasing function. So definitely reactants also, as time goes, it's going to decrease. But this time it's going to be exponential because you've taken only A. And if reactants are decreasing, then if you take products in the same place, it's going to be an increasing curve, okay? Right. Moving on, we'll go to more harder parts. Coming. Okay. So now let's go to something like LNA and time. So what reaction do you know? We know ln A by ln A naught by ln A is equal to minus Kt. So definitely it's going to be a negative slope. So, and this is going to be ln A naught. Cool? Okay. Next, let's try log. Okay, important. Let's see what is going to be the slope here. Minus K. Easy. Let's say I take log A and time. It's going to be the same. It's going to have a slope of log A naught. Sorry, intercept. And what would be the slope? It's going to be minus K by 3.20. Sorry, 2.303. I'm sorry for the stuttering, guys, but I promise you I'm telling the right information. Okay, moving on. We also have another kind which could be done, like ln A naught by A and time. a straight line through the origin, and M is going to be K. Remember, it's A naught by A naught, A by A naught, because I'm sure you know there is a change in sign when that happens, and that's why here it's a positive slope. And if you take log A naught by A and time t, again have a straight line, but this time M is going to be K by 2.303. Simple, cool, awesome. Yes. This is all about first order. Now, as promised, I also want to tell you guys a little bit about second order, because second order, first of all, it's so easy. It's not that hard, I promise. You just have to remember how you can derive the equations. Maybe we can do that in another video, but that's a kind of whole new topic, because there's a lot of different kind of questions there. But here, for second order, so initially a simple situation is this. You already have one formula. Now another formula, after you do all the integration and stuff like that, you're going to get 1 by A is equal to KT plus 1 by A naught. Cool? And you're going to get T half to be 1 by K by A naught, okay? Everything is a little bit weird here, definitely, but they're just few formulas and few diagrams, so I don't think it's going to be like rocket science, okay? Let's just be chill about it. So let's take the first. I'm going to take 8 as well as A squared. Simple, we know the reaction. Oh, why is it not a straight line? Okay, whatever. Next, I have weight versus only A. Remember, we have square. So y is equal to mx squared form, or it's going to be a parabola. Chill, cool. Okay. Next, we have T half as well as A naught. It's going to be an hyperbola. How? Because you can see this is the formula. T half is 1 by K A naught. Cool? Okay. Moving on, we have this. Basically, it is 1 by A versus T. It's definitely going to be a straight line, but it's going to be a straight line with an intercept, and it's going to be a like positive slope and not a negative slope. So how does that work? It's going to be something like this, and this is going to be 1 by A naught, and the slope is going to be simple K. And how does it come from? From the formula 1 by A is equal to KT plus 1 by A naught. Right, so I think we've done with the graph part. Now, we're not done here, but there's this one question, okay? Today, I had a mock test, and there was this one question based on the same topic. It's literally just graphs. But the question itself was so confusing. I couldn't even have time to think and analyze the question to be able to get an answer, right? So we're going to be doing that because it's for the best, okay? Let me go take the question paper. Okay, I got the paper. Alright. So let me tell you guys a question very clearly. For a first order reaction, let me just write the keywords because it's important. So it's a first order reaction. For a first order reaction, they've given a reaction as well. Okay, for a first order reaction of this reaction at constant volume and 300 Kelvin, the total pressure at the beginning and at time t are P0 and Pt respectively. Initially, only X is present with concentration X0 and T1 by 3 is the time required for partial pressure of X to reach 1/3 of the initial value. The correct graph is, okay, now I don't know, I still don't understand the question, so let me read it at least a million times before I'm gonna see the answer, because you'll have to do this even in the exam, because you'll not have an answer, you'll not have a key, you'll not have a hint. So they're going to reaction, they've told volume is constant, they've told a temperature is so much, and they've told the total pressure at the beginning at time t are P0 and Pt respectively. P0 and Pt at time t, the total pressure at the beginning. Okay. Initially, only X is present with concentration X0. See here, they're also talking about concentration, they're also talking about pressure. That was something that still confused me. And then they're talking that T1 by 3 time for partial pressure of X to reach 1/3 of its initial value. Okay. I think for this question, we also have to know the knowledge of first order gas phase reaction, because in the NCRT there is also a particular paragraph which talks about first order gas phase reaction, and I think there is something, not something, but there's a lot to do with that part. Okay, pressure, initial pressure P0, after time t it is Pt. Okay, let me just do it. Okay, so usually at time 0 initial pressure, no pressure. After time t, 2x, x, okay, and this whole pressure is Pt and this is P0. Let's see. Initial again. Alright. Now they've told initially only X is present with concentration X0. Now they talk about concentration. And T1 by 3 is the time required for partial pressure of X to reach 1/3 of its initial value. 1/3 of P0 is what we need to find out. But for that, it's still confusing, guys. Do I have the answer? Do I have everything with me? No, let me just show you the first graph, which is rate constant. Yeah, I'm not even kidding. It's not rate, it's rate constant and x0, and they've given this. And we just have to find whether it is correct or not. Now, for a first order reaction, we did learn that it's something like this. And I don't know about R, but they've given K in this. So even if I consider it in a different way, I don't think it's based on until K. So I just can't barely tell it to. But yes, honestly, rate constant does not depend on concentration. because the unit itself is per second. So I think I'm gonna go with it. And let's say A is also there. Now the second option is there's this. Doesn't fully do it is, but like T1 by 3 it is. And actually if it's half, then I could figure it out. But it's T1 by 3 as well as X naught. And again, it's not just pressure that we're dealing with, we're also dealing with the concentration of X here. So okay, let me just check the answer key. This is way too head breaking. But I think after I check the answer key, I'll actually know how good of a question this is and how good there are chances of this coming in the examination. Right, so let me not waste time. I'll just get the answer key. I think we've thought enough. Let's just work on it. Question number 81. Right, so they've done these. They've done this part. They've come under P0 plus 2x stuff. But then, yeah, they're actually putting it in an equation, which is, oh, yeah, I do have K. K is equal to 2.303 by T log P initial, and I think this is to P naught minus PT. So what is PT? We have 2P naught, P naught minus 2x. So it's gonna be, is it? But they've got 3 P naught from. Hmm, I don't get it still. Because the next option would actually be this one, which is ln 3p naught minus p total with the time, and it's a decreasing slope. And the last option is something like this, decreasing slope t ln p naught minus p. So definitely there would be something between c or t. It's not going to be both, but it's actually this. But how did they get the 3p naught is my doubt. Okay, so this is definitely head-wrecking. So we'll be dealing this with another video. I'll come back, I'll find the solution, I'll give you the best explanation in the most easiest way for this really head-wrecking question. So then, as of now, I hope you guys understood all these important graphs. Till then, see you guys. Bye bye.